have done, hopefully. Not bad, right? Because you see, I spent 1 week to explain, right? Gone 1 week, aim, objective, what we will cover, what is your takeaway, and so on, right? So 1 week is not gone, right? But we took time to do it. You should know what is the takeaway. Now, okay, let's see this thing. ISDN we completed, right? I wrote a note in somewhere here. I see ISDN we have completed. Can somebody say yes or no? B channels, we did that. I remember. Tap on the chat panel and let me know. Yes, because we have to move on. Yes, okay. Let's move on. So ISDN, just see. I've shared it. Right? Yes. Okay. Now this we have completed. In summary, ISDN, this we did. Right? B channels are in Kanban. Okay, now let's move on to ADSL, right? Now, ADSL, this is what you have actually at home, right? ADSL line. So it's known as asymmetric digital subscriber line, right? Asymmetric, why asymmetric? In fact, there is DSL also, but you don't have it yourself about DSL. DSL is symmetric. In fact, digital subscriber line means symmetric. This one is called asymmetric. This is why your tone is asymmetric. Okay? So we have not done ADSL. Okay, we have stopped at fiber optic. No, it's lecture 4. We have not done 4 at all. Frame relay X25. No, I think we did this lecture. We have not done X25, frame relays, and I was telling you PAD and so on. So this lecture itself, slide 24, we have stopped. Okay, let me see. Now, wait, hold on. What lecture is this? This is lecture 4, right? So we stop on slide 24, right? Now, okay. Now, you see, we have ADSL. The technology is the ADSL. How you implement it, you can use fiber optic or twisted pairs. That's okay, right? The technology, the name is something. What you use to implement it is something else, right? So we use fiber optic at home you have. Now, let's see, right? In fact, what they do is that you see, in ADSL, generally with any type of... you see, ADSL permits what? The cohabitation of voice. You can phone. Nowadays, the phone is not like the plain old telephone service, right? The other one. The other one, you don't have electricity, you use to place a call or receive a call. Nowadays, what you have with ADSL, that is your telephone line is connected to your modem at home. Right? You know that. If there's no electricity, you can't phone now, right? Unless you have this plain old telephone. So you see, this is what is good about it. You see, it has a bandwidth from 0 up to, I think, 1,104 kilohertz, right? The bandwidth of the line, the frequency range. And they use 0 up to 4 kilohertz for voice. Then, right, one part is used for upstream, one upstream, that is when one frequency range or frequency spectrum is used for upstream. And then a bigger part for downstream. This is why downstream speed is higher than upstream. You will see that later, right? So this is ADSL, in fact, right? Give me 1 second. I just got something. I was expecting to receive something from somebody. Just give me one second, please. Head is phoning me. Let me see what it is about. Right. So let's go to ADSL straight away. There we are. So ADSL is a form of DSL, only that it is asymmetric. Right? A data communication technology that enable faster transmission over copper telephone lines. Right? Now, ADSL is capable of providing up to 50 megabits and support voice, video, and data. That is, you can transmit voice leisurely, right? Video leisurely, and data means internet connectivity or data packets. Right? So it is a number one broadband, right, in the choice in the world with over 60% market share. This is the most popular, technologies that is used to access the internet, to access your ISP and so on, right? This is the number one technology, right? 60% is very high. Then the remaining 40 is shared among the others, the older technologies such as frame relay, right, cable TV, X25, and so on, right? Now, what does it mean? The acronym ADSL, asymmetric. A stands for asymmetric, right? So the data flows faster in one direction than the other. It means that the download speed is faster than the upload speed. Data transmission has faster downstream to the subscribers than upstream. Now, it's normally like that, because people, you see, they don't upload so much. You, for example, you don't upload so much. You download more, right? All users among you download more than you upload, right? So digital, so no type of communication is transferred in analog form. So all is purely digital end-to-end, right? And modulated to be carried over the subscriber line, right? So LSL means subscriber line. That is the data carried over a single piece of copper loop to the subscriber premises. So it's very simple. That's fine. Now, okay. So DSL is a form of Bluetooth technology that uses existing copper telephone lines and provide a dedicated high-speed internet connection. One of the big advantages of DSL, that is notably IDSL, is that, right, they permit the presence existence on the same line with a traditional telephone service, right? And even ISDN. So they permit, you to use, you can phone, and at the same time, you can transfer data and visit some websites on the internet. This is accomplished by utilizing different frequency ranges. Above voice range. 0 kilohertz, I think, is reserved for voice, and above that, some for upstream, some for downstream, some for upload, some for download. Right? The range is 0 1,104 kilohertz, something of the sort. Right? So essentially, this gives two lines, right? Two lines in one. Right? In one medium, in one transmission medium, right? One for voice and one for internet connectivity. As I have pointed out, in earlier lectures, right? And which I'm reiterating today, is that you see, when you transmit things at different frequencies, even on the same media, they don't create trouble. You see? So if you want to transmit different things on the same media, use two non-overlapping frequency ranges or frequency bands or frequency spectrum, right? It will work fine, right? So when all is working normally, there should be no interference between the two lines. No, normally there is not. This gives DSL a potential broad customer base and helps minimize costs for service providers. You see, they don't have to set up any new lines. They just use a plain old telephone line. Right. So ADSL exploits the unused analog bandwidth available, right? So you see, 0 up to 4. This is for voice. This is for voice. It's known as PSTN. It's used for PSTN, that is public switch telephone network, right? This is PSTN, public switch telephone network. Then upstream, so there is a part of the spectrum of the bandwidth we don't use, right? 4 to 25. Then 25,000 or 25,800, and that is around from 25 kilohertz up to 138. This is reserved for upstream, so low frequency, you see. So this is why upstream speed is low when you upload data. Downstream is higher. It's a big frequency spectrum, 138 up to 1004 kilohertz, right? Or 1000 megahertz if you want to say. So ADSLs work by using a frequency splitter, right, device to split a traditional voice telephone line into two frequencies, right? It uses a splitter. ADSL offers more bandwidth to downstream. You see the spectrum or the range is higher compared to upstream, and the values also are higher, right? So this is why you download faster than you upload, right? Compared to this, resulting in faster download speed and faster download time of files. This is very simple. I put it in very plain language, right? So ADSL requirements: we need a phone line activated by your phone company for ADSL, a filter to separate the phone signal from the internet signal, and definitely ADSL. Any subscription supporting ADSL. You need to subscribe. It's not a free service, right? Now, ADSL architecture, you just see, right? So you have your ISP, right? Subscriber premises is mean at your house there. So this is a telephone, you can use a phone, you connect it to your modem, right? By means of a splitter, then you use your PC, whatever device you have, Wi-Fi device. Then you have the DSL line, right? Which connects to the central office at the ISP, right? So then you can go to the internet, you can even go to the public switch telephone network, place a call here, right? Or go to the internet, to some servers through the ISP to the internet. So ADSL inside your PC, your computer, ADSL modems connects to a standard analog phone line. So voice and data, so a splitter divides the existing phone line into two bands. Two bands means two frequency ranges or two frequency spectrum. Oh, this is the same. Spectrum, range. Right. So one for voice and one for data. So voice travels on the first 4 kilohertz from 0 to 4. Zero also should be included there. You see, when why is 0 included? Because at times there is something known as silence. Okay. You see, when you use a phone, suppose you place a call and nobody, and the recipient over there, nobody speaks for 40 minutes. Right? So it will be a zero signal. This is more known as transmitted silence. And what happened? Do you think you have to pay for it? Yes, you have to pay. Right? It's your problem if you remain silent. Right? So this is why it's from 0 up to 4. Now let's move on. So a channel, the higher frequency used for data, channel, right, into two parts. A larger one for downstream, internet data, and a smaller spectrum or range for upstream. Right. At the end of the telephone line is another ADSL phones company central office. Right. So we have one here and we have one at the ISPs, right? That is Mauritius Telecom's office. This modem also has a splitter which separates the voice from the data when they say. So telephone calls. So voice calls are routed to the company's public switch telephone network, PSTN, and proceed on the usual way. So if there is a voice call, you see, you can place a voice call either on a mobile phone or on a fixed phone. At times I don't have money. Right? Suppose my balance is 0. And I don't want to replenish, right? Refill it. And call to somebody on a mobile phone or another phone, fixed phone or landline phone, as we say, right? So internet request data coming from your PC passes through the ADSL modem, right? Up to the digital subscriber line. Multiplexer means that is a transmission. So there can be many editions. Your neighbor. On top, yours are so each one will have their own. To a high-speed asynchronous ATM line or an Ethernet network. In fact, it's not so much right that the lines. The SLAM links the ADSL line to ATM. No, ATM is not so much used nowadays. So in fact, The DSLAM link ADSL lines to an Ethernet or IP or the global internet, which is what? Which is a big IP network, which intends connect to the internet at speeds of 1 gigabit or better. So back to you, when the signal comes back to you, the data you request is retrieved from the internet and routed back to the DSLAM and ADSL modem at the telephone company central office before coming back to your PC, right, for your wired connection. So in conclusion, right, ADSL. So ADSL advantages, simultaneous, right, internet and voice, even fax capabilities over a single telephone line. It's an uninterrupted high-speed access that's always online. It's a cost-effective solution for society because we don't need much devices, right? The telephone poles are here. We don't have to place new ones unless there is somebody who is living remotely on the foot of a mountain. Then maybe they will, right? You will have to incur the cost, in fact, when they place a new electrical pole, right, to fix the line. So data security that exceeds other technologies. So fast download speeds, that's true. ADSL provides speeds up to 8 megabits downstream, right, and up to 1 megabit downstream. Now, all this upstream and downstream, it depends on the package that you're taking, right? If you take a package which is expensive, you will get more. If you take a package which is cheap, definitely, you will get low upstream and low downstream speeds, right? So disadvantage is distance sensitive. Yes, it can't travel a very long distance, right? You can't place a ADSL line from here up to, right, many hundreds of kilometers away, no? Right. Definitely, the disadvantage also is slower upload speed due to the low frequency range or spectrum allocated to it. Right? Phone line and specialized equipment, such as a ADSL modem, is required. Definitely, we'll use ADSL modem. So ADSL needs to extend the distance, right? The access distance, because it's limited to it's a limited distance, right? So it needs to be standardized also, because ADSL, for example, it doesn't work with all equipment. Suppose you have an ATM network at home, it may not, right, synchronize with an ATM network. In fact, there is no provision made to connect to another type of network, such as ATM network to it, right? So the ATM modem takes time to synchronize the DSL signal and the computer connection to the subscriber's computer. This you know, right? It's not plug and play. You see a modem. If you turn it off, or when there is a power cut, it takes at least 2 minutes, right? I think 1.5 and 2 minutes, or even 3 minutes at times to synchronize. It doesn't work almost immediately, no. This you know very well. Now, last part of the lecture is known as cable internet access, right? So in telecommunication, cable internet access, right? It's also, you see, most of textbooks relate to it as cable internet, right? So in fact, it provides internet access, but they call it cable internet. Right? So cable internet is a form of broadband internet access that uses the cable telephone infrastructure, right? So it uses the television infrastructure. The other one uses the telephone infrastructure. This one, the television infrastructure. Just like, you know, the digital subscriber line and fiber to the premises, right? To your premises, cable internet access provides network edge connectivity. It's known as last mile access from the internet service provider up to you, right? The subscriber, which is you or the end user, as we want to say. So it is integrated in the cable television infrastructure, right? Just like ADSL is integrated in your existing telephone network, right? So this one is integrated where? In your cable television infrastructure. Nowadays, I will tell you frankly, it's not very popular. Right? In the past, it was popular when we had a powerful television infrastructure. Nowadays, most television infrastructure don't use cable, but they use what? They use, right, a very powerful antenna and get satellite communication from satellites, right? So, for example, you have Canal satellite. You see, this is why they say Canal Sat or Canal Plus, Canal Sat, right? Because it's receiving. So we need to orient. They come, right, with an antenna, right? It looks like just like a downlink. You remember when we did satellite? A circle, then a basement there, which is triangular, right? So cable TV networks and telecommunication networks are two predominant forms of residential internet access. You see, in networks, just like university, right? University, we don't need that. right? In university, we don't use that. We don't need this, right? What we need, we have our own LAN, we have our router, right? And then we can have a fiber optic cable which connects us to the ISP if it's not far away, right? Now, this cable internet access, right, and ASDL is meant for, right, users which are at home, right? For users, for subscribers which are located at home, not in a LAN, right? In a LAN, we use different technologies, right? It's not exactly this, right? So recently, both have increased competition from fiber deployment, wireless, and mobile networks. Definitely, mobile is very popular nowadays, especially if you go for data, right? That is mobile data. Now, cable internet access, the hardware and bit rates. So broadband cable internet access requires a cable modem at the customer premises, that is at your premises, at your house, and a cable modem termination system at a cable operator facility. So we need also a cable modem termination system at the ISP's premises. Right? These two are connected via coaxial cable or hybrid fiber coaxial plant, right? So they also use, in the past they were using coaxial cables. The problem with coaxial cable and all these cables, not even copper, UPT cable, is that inside the wires there are cables, right, which are made either of some good steel or copper. But the problem with that, with time, they rust and break out, you see? So this is why people are going towards fiber optic, right? So this one, it uses a special type of fiber optic plant known as hybrid fiber optic plant, coaxial. Right? So while access networks or sometimes refers to as last mile technologies, cable internet system can typically operate where the distance between the modem and the terminal is up to 160 kilometers. You see, this is in fact its strength. This is its strength, right? So, for example, you see, if somebody there is a new, right? You have a new neighbor who lives on the foot of the mountain, right? And the last residents were ADSL is granted, right? Is allocated, is some 5-6 kilometers away, right? So they can't extend, right? The wire, you know, whatever signals they're sending, they will attenuate, especially the voice, right? The voice will become a problem, right? The internet connectivity may work, right? You see, because these lines, ADSL, for example, it transmits both low noise and you have also internet connectivity on it. Now, noise won't go a very long distance, right? But this one, what is good, you see, it supports up to 160 kilometers, which is really fantastic. So downstream, the direction towards the user bit rate can be as much as 400 megabits per second, which is in fact very appealing, right, for business connection, and 200 megabits for residential service, right, in some countries. Now, all this depends, I won't ask you about this in the exam, was this 100 megabit or 200? All this is how much the type of package you're taking, right? You know this, right? Even in planes, you have to take a package as a business class or economic class. So the better service you want, the higher you pay. This is where it goes. So upstream traffic originating at the user ranges from 384 kilobits per second to 20 megabits per second, which is not bad. And downstream channel can handle hundreds of cable modems. So what is a cable modem and how does it operate? So a cable modem is a digital modem that uses coaxial cable connection for data transmission. This data connection is received by cable modem that decodes the signal from your PC into your PC. So cable modems are up to 10 to 20 megabits. Is a offer up to 10 from 10 to 20 megabits, even more nowadays downloads. So typical download speeds are 300 kilobits per second or close to 100. This is what you see. You yourself, you have 100, not 50 megabits per second, right? Your line. Do you ever get this 50 megabits? You will never get it, right? In fact, I wonder why people are not complaining, right? You never get this. I have 20, I think. Right? I never get this 20 megabit when I download. Never. Right? Maximum 1 megabit, 2 megabit, 3, 5, 6, 7. Never this 20. Right? Later you will understand why this is so. Right? So, but the speed of the modem depends on two factors. Right? First, it depends on how many users are on the system. Since cable technology is a shared bandwidth. You see, the problem here is that the bandwidth is shared. Right? So when you share bandwidth across many users, what happens? Right? Each one get only a portion of the bandwidth. It's just like, you know, when you're sharing at home, right? Suppose you have 20 taps in your residence at your place, right? If nobody is using, right, you enjoy, right? The water comes at a very high rate. But then when everybody is using, then you will say, okay, close the tap, I'm buffing or something like that. This will normally happen. So it's a shared technology. So the more your users contribute to the system and use it, the less memory it uses. So too many users using too much throughput can drain the shared technology. Definitely, at one point, it will become poor a system that you say I better don't use it. The second factor to cable modem is a limit on the modem itself. Some cable modem providers will limit the upload or download speed on the cable modem, and this will affect your telecommunication connection or communication speed. Now, coaxial cable is widely used in urban areas to distribute, right, television signals, right? You see, as I told you before, I don't know was it I am right here or wrong. I don't know whether you know these cables which you had in the past, which is you had an antenna there on top of on the roof of your house, and then they had a black cable which connects to the back of your television with a socket, right? A round socket. Now this cable, when I was looking at it, when I was working as network consultant and engineer also, my TV was not broadcasting well. So I had to, this connection on the back, it had become loose. So I had to cut a piece, readjust it, plug it there, then it worked perfectly. So I took this piece of cable, which is a black cable with a copper wire, right, in the middle, and then some protection there. There are a sheet which is protective over it, right? So I brought it to my workplace and I cut a piece of coaxial cable. I was looking at the two. Then I mixed up the two. I could not even recognize which is which. They look so much the same, exactly the same. Right? Regrettably, I did not test it and see whether it works just like a coaxial cable. It might be the same. Right? So enhanced cable modem enable two-way, high-speed, two-way, that is bidirectional, high-speed data transmission, using the same coaxial lines that transmit cable television. Right? So here is the architecture of it, sort of. Right? So anyway, I don't expect you to know this architecture because it's changing from day to day, and it's not very popular today, this cable modem, cable TV. So here too, cable modem. So this you can read on your own. I won't examine it. So you should have a broad idea about it because you see this technology is phasing out. It's not good to study all technology. It's good to know that they existed. Now, cable modem over ADSL, right? So there is one major advantage that ADSL have over cable modem. So cable modems use a shared network technology where all cable modems share a single pipe to the internet. You see all the cables modems that you have, which are, at this residence or other residence, then they're connected to a common pipe, right? A common pipe means a common cable to the internet, right? Now, definitely, if many users are connected there, right, using different frequencies, definitely what will happen, right? There will be a degradation in performance, right? Just like when you have too many cars on your road, definitely the car will go slower when you have a single car compared to when you have a single or 10 cars on the highway. So the speed will fluctuate depending on the number of subscribers connected to the network, right? Now, when ADSL is used, the pipe to the internet is for you only. You see here at home. Right? Your connection, ADSL connection, is for you. Right? Now, definitely, if somebody else is using, that's your problem. You are sharing your link, right? Your passkey, right? Password to somebody. So when two or three are using, then definitely the performance will degrade. You will observe a degradation in performance. Even me at home, right? If they're watching TV there, right? Especially Mauritius TV, and others are doing online courses, my daughter, for example, I see a degradation here. There is a lag when I use this, when I conduct my online lecture, right? So when a DSL is used, in fact, the pipe is only, the cable which is used is only, it's not shared. It's only for you. But if you want to share it with your members of your family at home, then definitely, right, you will expect a slight degradation in performance. But the cable is yours. There's a cable is shared across many users, right? So this allows for a more consistent speed, right? And this speed does not typically fluctuate like cable modem networks. Now, that's good. So, Vijaya, let me see. How many lectures we did cover? We have to do lecture 7, right? Oh, multiplexing and okay. Now, there's one thing that I need to tell you. You need to start doing the tutorials, right? There are 4 of them. They are not very big tutorials. Each tutorial, I think, has 4 questions, right? So do one every day. So if you see that you can't attempt it because we have not covered the chapter yet, the lecture yet, you leave it. Later on, you get back to it, okay? Start doing it because soon I will correct the tutorial online. Then we will do a test, right? Before the end of the semester or towards the end, right? This, we agreed on this. We will do, I won't do a test when all the others are doing on the same day or on the same week, right? So we discussed this in the last lecture and you all agreed that we will do, right? Separately, then you will dedicate all your time to my test, right? And you will perform well. I think this is better. Last year, we got very, very excellent performance, in fact. In fact, remarkable, I would say, performance in the first test, because we did it a bit after the others, right? Not the same day or the same week. And the performance, the students, they dedicated their time to my lecture, my material only, and they did very well. Right? So you need to practice the tutorial first. We will first correct the tutorial, then we will do the lecture. You see, the module is bulky. It takes time. It's not one slide. This one is 32 slides long. It takes time to cover, right? Now, okay. So let's move on to the next lecture, which is lecture 7. Now, what we will cover in the next lecture, I think, is about multiplexing and modulation techniques, right? Multiplexing, you see, as I told you before, right? If you have a shared medium, right? It's like, let me see if I see a cable here. Anyways, this is a mouse. Shared. Suppose this is a cable. Suppose this is a coaxial cable and it is shared. That is, many computers are connected here, somewhere, and here, right? So it's a shared, right? Technology, right? How many packets can you transmit over this shared cable? One packet at a time or many packets simultaneously? I told you that before. You should know now. Okay, type on the chat panel. Suppose we have a shared medium, right? You see, in bus topology, normally we have this shared medium, right? In bus topology, you have a coaxial cable and computers are connected to it, right? Using a T connector. And at the end, there is a T connectors, and to absorb the signal, there is something. T connector. And then I've worked with this so long, I've forgotten. T connectors and it absorbs the signal, it prevents it from reflecting. T connector. Then, anyway, I will remember it, I will tell you. So you see, we have bus topology. Bus topology, you have a coaxial cable. Then, right, after each 1.5 meter, you have a T connector. Then to the T connector, a computer is connected by means of a cable. Then another 1.5 meter, right? Or 1 meter, depends the configuration. You have another computer which is connected, right? So this, the one which allows the connection to computers are known as T connector. It's like a T, right? Which is placed on the cable. Then at the end, you have 2 circular things which are connected there. Right? This is used to absorb the signal so that the signal don't reflect back and come again. Otherwise, it will circulate indefinitely on the cable. Right? So when you send something, suppose this is the cable, right? When you send something there, it goes in both directions like this. Right? Don't think it will go in one direction. No, it will go in both directions. Right? The signal, it will go both. So when it reaches this end, right, if it may reflect and get back, and it comes to end, reflect, but this is not good. This is why we have a special equipment, a device which is fixed, plug at the end of the cable to prevent this signal from reflecting back. What is the name of it? T-connectors and let me think. What's the name of this? T-connector and what is the name of this thing? Okay. Means know how. T-connector is also known as T-junction. Then on the end, absorber. No, it's not absorber. Oh, let me check for it. Let me check. I will lose time with this. Is not important. Terminator. That's the word. Terminator. Terminate. It terminates the signal. That is the signal don't get back. Terminator. Right? That's it. Now, so well, I'll ask you a question, right? Can you answer anybody? How many signal can you transmit at a time, right? On a shared medium? One, exactly. It's one. Right? You remember I was telling you about colored water. If you transmit red water, somebody is transmitting blue water, then what will happen? It will mix up. In fact, what happens is that it is a digital mixer, right? It has this form, right? 0, 0, 1, 1, 0, 1, 1, 0, whatever, right? In fact, the packets will collide with one another. In fact, they will overlap and cancel out. This is what happens. This is known as a collision, right? So to permit multiple concurrent transmission over a shared medium, then we need a device known as a multiplexer, right? So multiplexer, right? It multiplexes. Multiplexer means adds, right? Adds up multiple concurrent, multiple packets or multiple signals together and send it over the shared medium, right? Let us see what it is. It's very simple. Just a minute. Now, signal propagation delay. Let us first, there are two definitions which we have to know. There is always a short but finite time, delay or means time, for a signal. It can be electrical signal, optical or radio signal, to propagate or travel from one end of a transmission medium to the other end. This is known as a transmission delay and is denoted by TP, right? Now, when you learn definition, don't learn it, right? You should know what to pick up from a definition, right? There is a short, finite, delay time. Right? Yes, there's always a short, finite delay, right? So what it is, in fact, right? Transmission delay is simply the time taken for a signal or a packet, if you want to say, right, to travel from one end of the medium to the other end. That's it. As simple as this, right? This short, finite, we know it's finite. It's not infinite anyway. Right? So it's the time taken for a packet or a signal to be transmitted, right? To travel from one end of a transmission medium up to the other end, right? So it's very simple, right? So round trip delay, right? So data is normally transmitted in blocks, that is frames, right, of bits. In fact, it's a series of bits. Upon receipt of a block, right? That is, a block means a packet, right? An acknowledgement or correct of correct receipt is returned to the sender, right? In fact, this TCP does this, right? And we mostly use TCP. So when you send a packet, if the destination has received it, it will send back an acknowledgement to the sender, right? Which means that the packet has been properly delivered, right? So an important parameter of a data link is therefore the round trip delay, right? Which is associated with the link. It is a time between the first bit of a block being transmitted by the sender and the last bit of its associated acknowledgement being received. Right? En fait, il peut compliquer un peu, là, moi explique exactement. So suppose this is a medium. Right. Now, Gregory has written terminators here. I'm sorry, I did not say it earlier. You should have turned on the microphone and tell me. I've forgotten about this. It's the first time, in fact. Anyway, this is not much used, bus topology nowadays. I've used it in one of the CITS sub. I remember when I was new at the university, I was trying a lot of things. There was a network software which runs on an OS. So it's sort of a middleware, right? It was known as Novel Network, right? So it permitted, connectivity between a sender and many destinations and a server and so on. It was good, though. It was good, but very, very complicated to implement. This is the one thing that I got most trouble to implement. In fact, when I came, I saw this in a wardrobe, in one of these filing cabinet. I saw the box. It was open. It practically new with some CDs there and then a user manual. That's all. So I was asking people, have you ever tried this? Then there was another engineer who was elder than me. He told me, look, I've tried, but you will get a gadget, throw it away. I said, okay, let me try. In fact, I took practically 1 month to make this work. But it worked well. Right? It was very difficult. And this one, in fact, this Novel Network, you can check for it if you want. It works. It's a red box. I remember it was a red box. And it works on bus topology, no other topology, only bus. Star topology or hybrid topology, ring and star, whatever combination you want, it won't work. Only bus. So I had a chance to work on bus topology with the terminators, the connectors, and whatever. But bus topology is it's the poorest topology that you can use. Right? If the terminator, somebody unloose it, the networks go out of operation. It won't work. If the T connector is loose, it won't work. Somebody takes the wire, just pull it, right, a bit hard, it stops working. Right? So it's very, very problematic. Now, okay, let's go to this multiplexing. Well, no, sorry, I was right. Now, round trip delay. What is round trip delay? Is this. You see, in Creole, on fait, parfois nous venons dire comment nous battons un carré, nous venons, non? Vous entendez, hein? Voilà, moi, pas connais pas assez série. Ouais. Et attends-moi le bâton carré, moi, venir. Ouais. Parfois, je suis camarade, une gueule, bon, des autres parents. At times, you tell your parents, we'll go for a square. Right? I don't know how to translate it in English. It's a typical Creole word. Right? What happens? You go somewhere and come back home. Ultimately, you have to come back home. And wherever you go, you have to come back ultimately home unless you have a house for yourself. So, round trip means what? Measure the time from going there and getting back, right? So round trip is what? When you see a packet is what? It's a series of bits, right? So this is the first bit. It can be a 0 or 1. The last bit can be 0, 1, whatever it is. So when the first bit has reached, right? And then you get the acknowledgement for the last bit, right? So it's what, in fact? Right? The first bit has reached, it means from you to the destination, right? First bit has reached, the first one itself, right, in the packet. Then the last one, right? The last one, when it comes, you get an acknowledgement. So in fact, broadly what it is a distance, right? For the packet to go there, right? We measure the distance and back to you, right? So if we want to say, what is the time taken, right? So round trip delay, suppose it's 10. I ask you, what is the time taken for the packet, any normal packet size from you to the destination? You take the round trip delay, you divide it by 2. So you will say it's roughly there, 5. 5 to go there and 5 to come back because the total is 10, right? So these are two definitions, transmission delay. Transmission delay is the time taken to traverse a medium, right? Round trip delay, right? First bit being sent to the destination, get the last acknowledgement for the last bit, right? This is a round trip delay. right? So now multiplexing, right? Why multiplexing? As demand, right, for bandwidth continue to increase, there is a pressing need to maximize the usage of existing network facilities. You see, when we have bandwidth, right, I would advise people to use it to the maximum. It's an expensive resource, right? So when people abuse, then you disconnect these people. Otherwise, use it maximum, right? It's just like, you know, if you pay, right? You pay if you want to go, right, to spend a day at a hotel, and they charge you a lot of money. What will you do? You will eat least, drink least, right, and go to visit the swimming pool least, or you will take maximum advantage. You will take maximum advantage, right? So, right, today I was speaking to some staff of the university. I was telling them, look, if you have bandwidth, let people use. This was my policy. You see, it's an expensive resource. If you have it, let people use, right? Because you're paying for it. Or when people abuse, for example, they are going to Facebook or YouTube, while they should do the lab, then you block them. But otherwise, let them use. It's an expensive resource, right? So you see, if you have a line which has very high bandwidth, right, and you pay a lot, right, for usage of that bandwidth per month, and only one packet can go at a time, right? Does it make sense? It doesn't make sense. So we should find a way to maximize the usage of the bandwidth. What comes into play? There is something known as multiplexing, right? So what do we say? Under the simplest conditions, a medium can carry only one signal at a moment of time. That is, right, what we say, only one packet can traverse a medium, right, at one point of time. If two packets traverse, then, right, there will be collision of the packets, right, and both will be lost. So for multiple signals, that is for multiple packets to share one medium, the medium should somehow be divided, right, and giving each signal a portion of the total bandwidth, right? So multiplexing is a process used to combine multiple signals, be it analog or digital, for transmission over a single shared media. Normally we say single media. It's better to say a single shared media. Otherwise, we don't use multiplexing when you have star topology. You see, in star topology, you have a hub, right? And all devices are connected to it using their own cable. The cable now, right? So each user has all, right, the line for himself or herself, and they enjoy the full bandwidth of the line. It's not shared. So when it's not shared, then you don't need multiplexing. Multiplexing, when you use a single media, multiple users are connected to that media, and the bandwidth is shared, right? So what we do is we use multiplexing, right? So there are four current, right, multiplexing techniques that are used to accomplish different things. One is frequency division multiplexing. The next is time division multiplexing, right? Now, time division multiplexing, it is divided into two categories or two groups. You have synchronous time division multiplexing and also asynchronous time division multiplexing, right? Asynchronous or statistical, right? Right. Asynchronous, another word for it is statistical. There is also medium wavelength division multiplexing and code division multiplexing. Now, let's see. You see? Now, listen to me well. Frequency division multiplexing is used to transmit multiple concurrent analog signals. Remember this one. If people want to use multiplexing and they ask you what among these four categories of multiplexing is best, I want to transmit analog signals. If analog is purely frequency division multiplexing, there's nothing else, right? For packets, for digital data transmission, right? Packets, zeros and one, whatever it is, right? Any combination of zeros and one, packets, right? Digital or binary signal. Then we use what? Not frequency. Frequency for analog. Note this one. We use time division multiplexing. Right? We can use synchronous time division multiplexing or asynchronous, which is also known as statistical time division multiplexing. Right? When we use light, pulses of light to transmit data. In what type of medium do we use pulses of light to transmit data? Tell me, type on the chat panel. We just covered this in some lecture before. Where do we use light to transmit data, not electronic signals? Fiber optic or optical fiber? Well said, Mohammed Tariq. No. That's it. Right? Very good. Fiber optic or optical fiber cable, both are equally good. Right? So that's it. So when we use light, right, light of different colors, right, then we use wavelength division multiplexing. Right? So you should know this well. Frequency, what? Analog signal. Digital, binary signal, packets, time, anytime, any of them, synchronous or statistical. Third one, light, fiber optic, only one, wavelength, division multiplexing. Then for mobile telephony, mobile communication, we use code. This one we will cover when we do mobile, right? In the next semester. Okay. Right, let us go ahead. We have some 5 minutes. Let's go. I won't take more than 1 hour to encourage you. Otherwise, right? If we do 2 hours, this is an additional lecture. I'm taking my time to do it because we will do also. I sent my email. I don't know. I think tomorrow, no, demain, we will do 2 hours, full 2 hours. This one I'm doing additional. Right. Now it's an additional lecture because we are a bit late. You see, we have a lot to cover. You see, I'm not making, you see, my job easier by covering less. You see, whatever I feel in these 20 lectures plus the self-study one, these are topics which, from my experience, I feel are very important. You should know in networking. I could have, you know, restrain this to some topics, 8 topics. That's all, right? Not 10. Right? Stay topics stretch over weeks. So first lecture, 3 weeks. Second lecture, 3 weeks again. I would have finished my job and you will, right? But this is not my way of working. Right? It's cheating. I'm doing only 2 things or 3 things, 4 things. No, this is what I expect you to know. If you know this, nobody, when you speak about networking, apart from the modules, which I hope you're doing very well, nobody will be able to challenge you. You can speak about anything. What do you want? The multiplexing, time, division, multiplexing, IP addressing scheme, what is broadcast, right? What is OSI reference model, right? What is cable TV, what is ADSL? Right? You come wherever you want. You will be able to face anybody, right? In an interview or otherwise. It's good, you know, to be good in all the modules that you do, not only networking by the way. Right? Let's move on to the lecture. Right, okay. Now, so signals multiplex at the sender should be demultiplex at the receiver, right? So you see, multiplexing is, look, you have what? Many inputs, that is n signals. We have only 1 links. Then we have created n channels. Channels means, right, different frequencies being used, right? Then at the other end now it has come as a composite signal, right? We have combined it. At the other end, we should let it go as here, right? As different inputs. The inputs has been combined into n channels on a single link. At the other end, we should right, perform a disassembly and package it because we have assembled everything. Right? So at the other end, we need a demultiplexer. Now, in fact, a multiplexer can perform the demultiplexing function. So you can buy a multiplexer here and a multiplexer here. So just for the sake of, you know, differentiate between multiplexing and demultiplexing, we use the word demultiplexing. But multiplexing and demultiplexing can be performed by new types of multiplexers which perform both functions. Just like a modem, it modulates signal and demodulates, right? So it performs both. Right? So multiplexing and demultiplexing goes in pair. Right? So okay, this is okay. Now let's come to more important things, right? Frequency division multiplexing, right? So frequency division multiplexing is the assignment of non-overlapping frequency ranges to each signal, right, on the medium. So one signal, just like you see when you receive, right, your TV radio channels at home, right? The medium is common, it's air, right? Voice is analog, right? When you hear something, it's analog. It's coming where? It's coming, right, using different frequencies, right? You will agree with this, right? So frequency division multiplexing is a form of signal multiplexing where multiple baseband signals are modulated on different frequency carrier waves and added together to create a composite signal. Thus, all signals are transmitted at the same time, each using different frequencies. So, a multiplexer accepts the inputs. In fact, it's the job of the multiplexer to do this, which is mentioned over here in this paragraph here, the middle paragraph. A multiplexer accepts inputs and assign frequencies to each device. The multiplexer is then attached to a high-speed communication line, which is the transmission media. Then a corresponding multiplexer at the other end, right, separates the multiplex signal. Right? Let me draw this and give you an example. I'm not very well on you. I think you have observed this from. Now, by the way, right? Try to bring I sent a mail for this. Try to bring your laptop if you have installed VMware and what? CentOS 7. Right, so log into CentOS 7 as administrator, then download the HTTP package. Right, I made a request, right, a very strong request to CITS and to our department to get the lab ready on Wednesday. I think it will be ready. I think you will be able to download, right? But with, I can't promise you. So I don't want to sit there idling and not work. So what you can do, you can download it at home, right? You know, I checked my mail. I've told you how to download yum-y install HTTPD, right? This is for web service. So download it at home so that you don't have to create this hotspot at the university and share, then get bandwidth to download, right? So download it when you come, then we'll start. Now, if the lab is working, it's so far so good, we'll download this straight away. It take a few seconds to download. But no, it's not 1 minute or 2 minutes to download and install. Right? So when it downloads, it installs immediately. You don't have to download like in Windows, then double click on it to run it to install. No, it will download and start it at one go. Right? Now, let me draw this and you will understand what we mean by frequency division multiplexing. Right? So just see. Then we will end on this note. Now, I'm sharing a blank screen. It's in Paint. Do you see? You should see normally. Okay. So what we do, you see, this is one station. It's used sending something right, at a specific frequency. Another one right, at another frequency. So what do? Right? We take this, assign a frequency to it, and send it. Right. Then the other one is